We can now use the circle that we've made and the trig functions that we've found based on this triangle, which has hypotenuse r for radius, to figure out how to calculate the trig functions when our ray is not just sitting in the first quadrant here with the angle theta being acute, but what happens when it moves around and it's in one of these other quadrants. But before we get to that, for the rest of the lesson, we're actually going to look at what happens when we go to find the sine, cos, tan, or any of these trig functions of 0, 90, 180, and 270. Because even though you can look these up by or calculate them by just punching them into your calculator, if you're going to calculate other angles, it's really good to have a proper understanding of where these numbers come from. Now, if we imagine, let's start with 0. So we've got here the point, we've got 0 degrees, 90, 180, 270. Now, don't forget these have many names, don't they? 0 is also 360, 720. It's also minus 360. We could add 360 or take away 360 from this many, many times. So there's no need to find 360 and to keep on going. These ones account for a whole lot. We could put dot, dot, dot in either direction for those, really, couldn't we? Okay, so let's imagine point P has moved along the circle here until it's sitting right down here. This triangle is going to get flatter and flatter and flatter, isn't it? And y is going to get smaller and smaller and smaller. It's going to get so small that eventually y will be 0. And how big will x be? Well, it will get bigger, won't it? It'll end up being this whole distance here, which is the same as r. It'll just be the radius of the circle. So x will end up being a radius. The radius is going to be the radius all the time. And we're going to just go and label what the radius is. It's always r. Now, if we go to calculate sine of theta, and we know that sine of theta is y over r, then if y is 0, we've got 0 divided by r. And 0 divided by something, well, that's just 0, isn't it? And that explains why the sine of 0 is 0, because if you imagine 0 being down, you imagine theta having no size at all, then the opposite side is 0, and so you end up with 0. What about the cos of theta? If x is the radius, we've got radius over radius, so we end up with 1. So the cos of theta is 1, which often surprises people when they put it in their calculator and they think, how can the cos of 0 be 1? But that's how it can be, because it's the ratio of the opposite side and the adjacent side, which end up both being the same, because this triangle is flat, isn't it? It's been like that, and it's come down until the point where it's flat, and the adjacent side and the hypotenuse are equal. What about tan of theta at this point? Well, we've got y over x, and y is 0, so 0 divided by anything gives us 0. Now, if we look at cosec, sec, and cot, something interesting happens. If you have 0 on the top of a fraction, that's okay, isn't it? So you can do 0 divided by r. But can you do r divided by 0? Anything divided by 0 is undefined. So we put in here undefined. And if you try and calculate that on your calculator, it'll just come up with an error. So anything that was 0 is 0 because it was 0 on the top of a fraction, but 0 on the bottom of a fraction won't work out. And that explains why the reciprocal functions of sine and tan will be undefined. Now, if cos theta was 1, because x and r were both r, when you flip that upside down, you've still got radius over radius, so it's still going to be 1. So sec theta and cos theta are exactly the same. All right, to look at 90 degrees, let's imagine that point P now has moved up. It's slid its way along here until it's sitting right here. Now, as it slides up, the triangle is going to change, isn't it? And y is going to get bigger and bigger and bigger until eventually y is the same size as r. So this is going to be another flat triangle, but instead of being flat, instead of being flat like this one, it's moved up like that. If we imagine this is the y-axis, it's moved up like that, hasn't it? Okay, now y is going to be the same as r, so y will be r. What about x? Well, as we move, x has got smaller and smaller and smaller, hasn't it? Because it's moved along and along and along until it gets so small that it's 0. So as we go to calculate our ratios, sine y over r over r is 1, and that explains why the sine of 90 degrees is 1. Cos of theta, we've got 0 because we've got 0 on the top, x is 0. And tan of theta, y over x, if we have r over 0, can you do that? No, so that one will be undefined. So if you put tan of 90 in your calculator right now, it'll come up as an error. It doesn't exist. And that's because there is no x. We're doing opposite over adjacent, and adjacent is 0, and we just can't do that. Now if we look at the reciprocal functions, something that we already learned, if one of these functions is 0, its corresponding one will be undefined. And we also learnt that if a function is 0, then if a function is 1, then its reciprocal function will also be 1, because if you've got r over r and you flip it upside down, you've still got r over r. So we have 1 here. Now, tan theta was undefined because we were trying to do y over x, which was r over 0. You can't do that. But when we flip it up the other way, it'll be 0 over r, won't it? And that will give us 0. All right, moving along to 180. Imagine this point has come all the way around here, and it's now over here. So we did have a triangle. Imagine it was here on its way down, and it's getting smaller and smaller and smaller to here. Let's have a look at what the values are that we have. If this is r, it's still r. X, well, x was over here before. Now it's out this side, and something's happened. Over here we have minus r. So if x is all the way over here, it will now be minus r. All right, now that seems a little bit hard to get your head around, but we've moved the imagine this point here, it's really minus x, y, isn't it, once it's in this quadrant? Because if you imagine this point here, see how it's negative on the x-axis, so it has a value of minus x, but it's positive on the y-axis, which explains why it's positive y. So as it gets all the way down here, x is equal to whatever this number is, and this is minus r. And y is going to get smaller and smaller and smaller, isn't it, as it ends up being tinier and tinier until it's 0. So calculating our ratios again, sine of theta is y over x, and you can't do that. Now notice that 0 and 180, they've got some things in common. Both of them were 0 for sine, weren't they? And the same thing's going to happen for tan. If we've got 0 on the top of a fraction, we get 0. For cos, we've got x over r, and because x is negative now, minus r over r is minus 1. And now when we do our reciprocal functions, the zeros become undefined. And minus 1 was that way because we did minus r over r. We'll get the same answer if we do r over minus r. It's still minus 1. And that was the same thing as what happened here with our 1s. All right, coming around to the last boundary angle, 270. Now this point down here, let's think what it looks like if we just label it P, X, Y. Now this point here is minus R, isn't it? And now that's on its Y axis. So this point really here, it's got 0 for its X value and minus R for its Y. So we can put those straight in. It's got 0 for its X value and minus r for its y value. So sine of theta, y over r, gives us minus r over r, which is minus 1. And cos of theta, x over r, we've got 0 over r, which is 0. And tan of theta is y over x. And you can't do something over 0, can you? So that one is undefined. Now, to flip these around, we've got a 0 here for cos, so its reciprocal function will be undefined. We've got minus 1 for sine, and we'll get the exact same thing for its reciprocal function, minus 1. And tan is undefined here, but that's because we were trying to do minus r over 0. We couldn't do that, but we can do 0 over minus r, and we get 0. Now, we need to write this whole table down. I know there's a lot there, and I know it's tedious going through all of the little bits and pieces to find out how to figure them out. But the reason we went through all of it is so that when you are faced with trying to come up with any of these by yourself, you could not only find the value, because after all we've said we could put these in the calculator to find, you could actually explain and prove why they're so with a sentence answer. And that's really important to be able to understand it fully.